So let's try now to find the square root from the mathematical tables. Let's start with the simplest. A. Let's find the square root of 3.6. And B. Let's find the square root of 3.67. And C. Let's find the square root of 3.675. 3.675. Now for the square root of 3.6, we look at the square root numbers from 1 to 10 table. Then let's locate row 3.6 and look under column 0. The value at this intersection is, just move at the square root of number 1 to 10, and then let's move at the column X where there's 3.6, and then we'll set at 3.60. 3.60 will give us 1.8974. 1.8974. And for 3.67, to find the square root of 3.67, let's locate row 3.6 where you are, the same table, and move horizontally to column 7. In this case, this will be our column. So 3.6, and we move to column 7. So 3.67, that will be so direct. 3.67, we have 9157, and since this column starts with the 1, so our answer will be 1.9157. 1.9157. 9157. Now let's look for a number with the 4 digits. For a number of the 4 digits, of course, the third digit will be our column, and this one will be what? Our main difference. So in this case, 3.67 Let's find the base value in row 3.6 and then column 7. The value will be, that is for 3.67, for 3.67, 3.67, for 3.67 we have 1.9157, 1.9157. Now let's look for the mean difference. Let's find the mean difference. In the same row 3.6, look at the mean differences section on the right under column 5. So 3.67 and then we'll move to column 5. 3.67, then we'll move to column 5. For column 5 we have 13. The mean difference is 13. The mean difference is 13. So our mean difference is 13. Now it's time to find the final answer. How do you add 1.9157 plus the mean difference, which is 13, place the mean difference on the last digits of our value? So 7 plus 3 is 10. This is 0. And then we carry that 1, get it 5, get 6, we add 1, get 7. Now we have a 1, we have 9, and then we have 1. So our answer will be 1.9170. 1.9170. Now that you know the basics, dive into practice problems. Let's find the square root of a number that's greater than 100. A number that's greater than 100. The square root of a number. No, we cannot. So let's find the square root of 321.7. The square root of 321.7. To find the square root of 321.7, let's first express it in standard form, because you cannot find the square root of a number that's greater than 100 directly from the mathematical table. So standard form. In this case, our standard form should be such that the exponent is even. The exponent is divisible by 2. So for 321.7, our standard form will be, we'll move the decimal here 1, decimal here 2. So it will be 3.217 times 10 squared. The exponent must be divisible by 2. The exponent must be divisible by 2. So let's just find it easily now. The square root of 3.217 times 10 squared. Yeah, the square root is the same as the square root of 3.217 times the square root of 10 squared. Now, the square root of 3.217, we can get it directly from the table. We'll start by 3.21 and then find the mean difference. Now for 3.21, we have, for 3.21, 3.21 we have 1.7916. 1.7916. 7916. And then from there we find the mean difference. The mean difference will be under column 7. The mean difference under column 7, that's 3.21, 3.2. Then we'll move to column 7 of the mean difference. That's 19. The mean difference is 19. And so when you add, we'll have 1.7916 plus 19. We place it the last digits of our value. So 9 plus 6 is 15. 5. We carry 1. It will be 2 plus 1 will be 3. Will be 3. We have 9 here, we have 7 here, we have 1.7935. Now we are going to multiply. We are going to multiply this times 10, the square root of 10 squared. 1.7935 times the square root of 10 squared. How do you find the square root of an exponent? You divide by 2. Divide by 2. So we'll divide here by 2. We'll divide here by 2. And when divided by 2, we'll have 10. So we'll have 1.7935 times 10. And when multiplied by 10, we'll move our decimal one place to the right. So our answer will be 17.935. 17.935. Let's look for the second example. The second problem of the square root of numbers that we can't get directly from the mathematical table. Like this number is less than 1, 0.138. Find the square root of a number that's less than 1. So the first step will be to change this to the standard form. Let's express it as a standard form, and remember that the exponent must be divisible by 2. So our standard form, will be such that the exponent is divided by 2. Now look at this. If you write it this way, this is just 1.38 times, this is just 1 times 10 negative 1. You won't find the square root because negative 1 is not even, negative 1 is odd, so we can't find the square root. The exponent must be even. The exponent must be even. So our standard form will be 0.138 will be, this is 1, this is 2. So we'll have 13.8 times 10 squared, because less than 1 it will be a negative exponent. So we'll have 13.8 times 10 raised to negative 2. That will be our standard form. This negative 2 here is divisible by 2. It's even. Now, the square root, we will find the square root of this one here. And this will be the same as finding the square root of 13.8 and then multiplying that square root with the square root of negative 2. Now the square root of 13.8, we can get it directly from the mathematical table. Just move to column X for 13, and then move horizontally to column 8. you'll get the answer is 3.7142. 3.7142. So here we'll have 3.71 for what? 3.7148 for 8. And then you multiply. To find the square root of an exponent, you just divide here by 2. And when you divide by 2, you'll get here 1 and here 1. So you'll have negative 1. So here we'll have 10 raised to negative 1. When you multiply these ones, since this is a negative exponent, we'll shift this decimal point to the right. That means we'll have 0.37148 and 0.37148. Let's look at the last practice problem. The last example, the last practice problem. Let's find the square root of 8174. Let's find the square root of 8174. We can't find the square root of 8174 directly from the square root of numbers, because this table can allow us to find the square root of numbers of between 1 to 99.9. Let me check. 99, yeah, 99.9. 99.99. 1 to 99.99. So if it's less than 1 or it's greater than 99.99, we have to transform it into standard form. Standard form. Such that the exponent must be even. Exponent must be even. Exponent must be even for us to find the square root. So let's find this. Let's transform this one to a standard form. We cannot write 8.174 times 10 raised to 1. We cannot write like this, because this one is odd. Yeah, this exponent must be even. Must be even. So the correct way of writing it in a standard form will be 81.74 times 10 squared. 81.74 times 10 squared. And then now we can find the square root. We can now find the square root. It's now simple, because we have 81.74 square root times 10 squared square root. From here, you can find the square root of 81.74 directly from the mathematical table. So let's move to our square root of numbers. Page 24, the square root of 81.74. Column X, we have 81. We move horizontally to column 7, so that we have 81.7. 81.7 is giving us 9.0388. So 81.7 is giving us 9.0388. 88. 1.7 is giving us 9.0388. Now let's move to column 4 to find the mean difference. Let's move to column 4 to find the mean difference. The mean difference in column 7. The mean difference in column 7 is column 7 is 39. No, it's not column 7. Column 4. Yeah, column 4. It's 1.74. So we are going to column 4, not column 7. Column 4. The mean difference is 22 in column 4. 22. The mean difference is 22 is column 4. So when we add, we have 9.0388 plus 22. This is 10, this is 0, this is 9 plus this is 11, this is 1, this is 4, this is 0, this is 9. 9.0410. Now this is the square root of 1.74. What about the square root of 10 squared? The square root of 10 squared, what we do is we divide the exponent by 2. We divide this exponent by 2. So it will be 10 to divide by 2. This is 1, this is 1. So the answer will be 10. 10 raised to 1 is the same as 10. So our final answer will be 9.0410 times 10. That's 10 raised to 1. That will be 90.410. 90.410. That's all.